In the Skellefteå district in northern Sweden, there's a long tradition of fieldwork. In the days of early exploration, the prospectors, or the people searching for the ore, they could basically go out here in the beginning of spring and come back home in the autumn. Basically spending all of the summer out in the field, looking for mineralized boulders or looking for ore. Something like 85 VMS deposits have been found. And of these, more than 30 have been mined, mainly by the Boliden company. In the last decades, we have been seeing a negative trend in the amount of field exposure in many of the geology educations. Much of the exploration today is actually being carried out from offices.
There is probably a trend in the universities to focus a bit less on teaching the practical field skills than, let's say, I don't know, 10, 15 years ago. And I think that we can see the effects of that in the students that comes to us. But that said, I mean, I can definitely see that there are differences between universities and even countries in Europe. So there are really good examples as well.
The course Applied Field Exploration is a short course created by Luleå University of Technology with funding from the European Institute of Innovation and Technology. The course combines practical field exercises with digital e-learning tools, which allow you to explore parts of the Skellefteå VMS district deposits and learn about key field methods and exploration techniques.
Geology and geoscience have developed quite constantly and rapidly throughout the last years. Nevertheless, fieldwork still remains quite traditional. So you come pretty far with using a compass and a hand lens and a traditional field book.
We hear actually both from students but also from the companies that recruit our students that there's commonly a deficit in the amount of field exposure when the students finish their exams. You could say that we want to counteract this trend a little bit by at least providing an arena for field exposure in this course.
The digital part of the course is a fully interactive e-learning experience containing photogrammetric models of key outcrops, magnetic survey data generated by drones, detailed 360-degree photographs of the environment, and in-field video lectures that communicate key concepts, such as how to extract key information from outcrops and how to conduct sampling and measurements.
Modern technologies can be used as a complement for fieldwork, as a tool within fieldwork to make fieldwork more efficient, to get better documentation, to get faster learning. Drones are a good example of how modern technology can be used. You can make a very quick photogrammetry model. This takes maybe 5 to 10 minutes extra, and you can use a small drone or you can use a handheld camera depending on how the topography of the outcrop is. And these overlapping photographs from different angles allow us to make a 3D model out of the photographs. At Luleå University we have a virtual reality lab where we can open these 3D models and take measurements afterwards. We can revisit the outcrop there. We can communicate with colleagues, with other students.
There's a big difference with modern fieldwork in that we have access to modern technology. We like to think that this is not like a substitute for actual fieldwork. This is more like tools that should be aid to augment fieldwork and make work more effective. And this is of course very useful when you are in northern Sweden where we have a really short field season. That basically we have to maximize the data collection while we're out in the field.
All this digital data is available for students before the course, so students can go through the data, already get an impression of what can they expect, take structural measurements on the 3D models and already can develop their first ideas and then come out in the field, look at the rocks, complement it with actual fieldwork, hands-on, and this is something that we would like to emphasize in this course, to teach students how to combine traditional with modern methods.
A course like this, I think it's a great idea to use modern technology to create a virtual course where you can actually see the outcrops in 3D, you can learn how to measure structures, you can do all of these things that we do in the field. So I think even as a standalone thing, this course could be a good thing. But for the lucky students that actually get to go out and see the same outcrops as are shown in the virtual environment, I think this will be a huge benefit, because having that knowledge with you when you go out, they will be able to gain much more from the field experience.
So a general message to students is basically to take every kind of opportunity you can get to get field exposure, preferably in different geological environments. And that's basically what we want to achieve with this course, is that we want to present an opportunity to get some field exposure in one of the most famous VMS districts in the world up here in northern Sweden.